Welcome everybody once again. So in today's class, let us see the most economical section of channels. So most economical section of a channel is nothing but the best section or the most efficient section of an open channel. So a section of a channel is said to be the most economical when the cost of construction of the channel is minimum. So when the cost of construction is minimum, we call the channel as the most economical channel. Now, the cost of construction of a channel depends upon the excavation and the lining. So when you need to lay a channel, you need to dig the ground, okay? You have to excavate the soil. So the cost depends upon this excavation and the lining of the channel. So if these excavation and lining can be kept minimum, then that will be your most economical section. So for that, the condition is the wetted perimeter for a given discharge should be minimum. So at any section you take, if it may be rectangle, it may be trapezoidal, it may be circular, the wetted perimeter at the section should be kept minimum. Okay, so how can we keep the wetted perimeter minimum? How can we obtain the wetted perimeter minimum? We know for a rectangular channel, the wetted perimeter, we have two depth and one breadth, right? So we can keep the breadth constant and let us find the minimum depth to have the maximum discharge. So that is our aim for a rectangular channel to get the most economical channel. So in that way, so the condition is this is the condition, okay, this is the condition, that is the wetted perimeter for a given discharge should be minimum. So we have three different sections or three different channels. So we will find the most economical section for a rectangular channel, most economical section for a trapezoidal channel, and most economical section for a circular channel. So first of all, we will see the conditions for most economical rectangular channel. If the channel is rectangular cross section, what should be the dimensions and what should be the hydraulic mean depth? What are the conditions? So that the open channel flow when the section of the channel is rectangle will be economical. Okay, so first case is most economical rectangular channel, very important for your examination point of view. Okay, so you remember the derivation. See, derivation is very simple. Remember the derivation, and if not possible to remember the derivation, try to understand the important concept and the conditions. Okay, now we will derive the important conditions for the most economical rectangular channel. So we will consider a rectangular channel now. Okay. So this is the channel with a rectangular cross section. Consider a channel with rectangular cross section. We will take the breadth of the channel as B and depth of flow of water in the channel as small d. So this is the depth of flow of water in the channel. Okay. Now, so B is the width of the channel, width of the rectangular channel. D is the depth of flow of the rectangular channel. So now our area A will be equal to, so area of flow A is equal to B into D, BD. And we know the wetted perimeter P equal to, P will be equal to D plus B plus D. So it is B plus 2D. Now, we will take this area as equation number 1 and perimeter as equation number 2. So, from equation 1, we get B is equal to area by D. So, we will substitute this equation, that is B equal to A by D, in equation number 2. So, equation number 2 implies P is equal to, B is replaced by A by D. So, we get P equal to A by D plus 2D. We will take this as equation number 3. Now, for the most economical section, we will keep B as fixed. We will keep B as fixed and we will vary this D. See, we have two dimensions. One is B and another is D. Okay, two dimensions, breadth and depth. We will keep B as it is and we will try to vary the depth. So, we will find the minimum depth so that the wetted perimeter will be minimum. So, I repeat, see, the condition for the most economical channel is the wetted perimeter should be minimum. So, this wetted perimeter depends on breadth and depth. So, this breadth and depth is responsible for the area of a flow. So, it depends upon breadth and depth, and when you are replacing this B is equal to A by D, this wetted perimeter depends on area and depth of the channel. So, now we will vary this D. If D is varied, in order to find the most economical wetted perimeter, for a given area, dou P by dou D will be equal to 0. So, our condition is for most economical section, we know for the most economical section, so perimeter P is minimum for a given area. Okay, perimeter should be minimum for the given area. So, we are trying to vary this D. We are differentiating this perimeter with respect to D. We get dP by dd. This D is the depth, should be equal to 0. The condition is perimeter should be minimum. Sorry, wetted perimeter is minimum. Condition for P is minimum, right? So, we are differentiating P with respect to the depth because we need to vary the depth. So, we differentiate this, what we get is D by dd of perimeter is A by D plus 2D equal to 0. So, differentiating A by D with respect to D, we get minus A by D square. Here the variable is D, right? Here the variable is D. So, A into D raised to minus 1. So, when you differentiate, you get A minus A into D raised to minus 2. So, it is minus A by D square. Because we know differentiation of x raised to n is equal to minus x raised to n minus 1. So, here A is constant. Here it is A into D raised to minus 1. A is constant and differentiating D raised to minus 1. N is equal to minus 1 here. So, minus 1 into x is D, right? So, we get D raised to n is minus 1 minus 1. So, it is minus D raised to minus 2. That is why it is minus So a into minus d raised to minus 2. So it is minus a by d square. Okay. Plus differentiating 2d with respect to d, we get 2 is equal to 0, from which we get minus a is equal to minus 2d square. So we can cancel this minus and minus. We get a is equal to 2d square. But we know area is equal to b into d. Area is b into d is equal to 2d square. You can cancel this d and 1d here. So what you get is b is equal to 2d. So this is one condition. Condition number 1. That is, for the most economical rectangular section, the breadth should be equal to 2 times the depth of the channel. Depth of 2 times the flow depth of the channel. Breadth of the channel should be equal to 2 times the flow depth of the channel. This is your first condition. First condition for the most economical rectangular channel. Now, what is the second condition? Now we will find the hydraulic mean depth. We know the hydraulic mean depth m is equal to hydraulic mean depth m is equal to area by wetted perimeter. So area is b into d and the wetted perimeter is b plus 2d. Right? Wetted perimeter is b plus 2d. So now we have obtained for the most economical rectangular section b equal to 2d, right? B equal to 2d. So substituting b is equal to 2d, we get 2d into d by 2d plus 2d. So we get m is equal to 2d square by 4d. So we get d by 2. So which implies m is equal to d by 2. This is our second condition for the most economical rectangular section. So that's all. So for most economical rectangular section, for a rectangular section to be most economical, for an open channel flow, if the channel is of rectangular cross section, for the most economical rectangular cross section, the conditions are the breadth should be equal to 2 times the depth of flow, or hydraulic mean depth should be equal to d by 2. These are the two conditions, very, 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 very important. Okay. So, mean depth is equal to half of the depth of flow of water. That's all. So, for a most economical rectangular section is very simple. Hope you understood. We will move on to the most economical trapezoidal section. Trapezoidal section is not as easy as the rectangular section. Because we have sloping sides, it is little more difficult than the rectangular section. The simplest section is rectangular section. Okay. So here also the condition is, that is, for a trapezoidal channel should be to be most economical, the condition is the wetted perimeter should be minimum. So first of all, we will find the wetted perimeter for a trapezoidal channel. Then we will differentiate the wetted perimeter with respect to the depth is equal to 0 as we did for the rectangular channel. Okay. So first of all, we will draw a trapezoidal channel here. Okay. So this is the trapezoidal channel. So let us assume the depth of flow of water is up to this. So this depth is taken as D. Depth of flow of water is taken as D. B is taken as the bottom width. So we will find the top width now. So top width is equal to, we will draw a vertical line. So we will take the section as A, B, C and D. So now let us assume the side slope of the channel is 1 vertical to n horizontal. Okay. So if it is 1 vertical to n horizontal, see, take this triangle ABCD, E and F. Take triangle FCD. FD will be equal to, see, if vertical is 1, horizontal is n. Here the vertical is D. Vertical is D. So the horizontal will be ND, right? So FD is equal to ND. Similarly, AE will be equal to ND. And this distance is B. So the top width of the top width of the trapezoidal channel is B plus ND plus ND. ND plus B plus ND. So B plus 2ND. So this is B plus 2ND. Okay. Now let us take this angle as theta. So this angle, let us take it as theta. So this angle is theta. So if this angle is theta, what is this side slope? So side slope CD will be equal to square root of this D square plus ND square. So we can take D common. So D into, N square D square, right? So D into 1 plus N square. So this side slope is equal to D into square root of 1 plus N square. So hope you understood the different dimensions of this or the description of this rectangular channel. Now we will come for the derivation. So we know the area of a flow, right? So area of a flow A will be equal to half into this B1. That is first breadth, right? B1 plus B2, bottom width, top width into the depth. So that is equal to half into, so bottom width is B plus top width is B plus 2ND. B plus 2ND into D. So we get half of 2B plus 2ND into D. So from which we get, you can take 2 outside. So 2 by 2 into B plus ND into D, can cancel 2. We get area is equal to B plus ND into D. We will take this as equation number 1. Area is equal to B plus ND into D. So this B plus ND multiplied by D. Okay. So this B plus half this, B plus ND multiplied by D will give you area of the trapezoid. Now, we will write this area, we will write the breadth in terms of area. So we get B plus ND is equal to A by D, from which we get B is equal to A by D minus ND. This is equation number 2. So now we will go for the wetted perimeter. So we know the wetted perimeter. Wetted perimeter for the given trapezoidal section will be equal to AB plus BC plus CD. AB plus BC plus CD. AB plus BC plus CD. So AB is equal to D into root of 1 plus n square. Okay. So it is B plus 2D into root of 1 plus n square. So P is equal to B plus 2 into, because we have two sloping sides. So 2D into root of 1 plus n square. Now we will substitute the value of B in this equation. So B is equal to, B is A by D. So P is equal to A by D minus ND plus 2D into root of 1 plus n square. We will take this as equation number 3. Okay. So P is equal to. So from which we get P is equal to A by D minus ND plus 2D into root of 1 plus n square. We will take this as equation number 3. Now we know for the most economical section, P should be minimum. So for the given area, the perimeter should be minimum. We will vary the depth. So the condition is dou P by dou D should be equal to, or dP by dd. Okay. Anyway, you can write. So dP by dd should be equal to 0. So this is the condition. Okay. So what is the condition? The perimeter is minimum. Wetted perimeter is minimum. So now we will differentiate. What we get is d by dd of, so what is P? A by D minus ND plus 2D into root of 1 plus n square is equal to 0. So differentiating with respect to D, A by D, differentiating A by D, we get A by D square. Minus, differentiating minus ND, we get minus N. Differentiating this, so 2 into root of 1 plus n square is constant. We get plus 2 into root of 1 plus n square. Differentiating of D with respect to D is equal to 1. So that is equal to 0. So what we get is A by D square minus N is equal to plus N or minus N. Okay, it is minus A by D square, right? So minus A by D square minus N is equal to minus 2 into square root of 1 plus n square. So we can cancel this minus. We get a by d square plus n is equal to 2 into square root of 1 plus n square. Now we will substitute the value for area. So we know area is equal to, from equation number 1, area is equal to b plus nd into d. So b plus nd into d by d square plus n is equal to 2 into square root of 1 plus n square. Now you can cancel this square and d. We get b plus nd by d plus nd. So b plus nd plus nd by d is equal to 2 into root of 1 plus n square. So this is nothing but b plus 2nd by d or b. Okay. So b plus 2nd by d is equal to 2 into root of 1 plus n square. Now, see what is b plus 2nd? B plus 2nd is the top width of the trapezoidal channel. So we can take this 2 to the bottom. So we get b plus 2nd by 2 is equal to d into root of 1 plus n square. So b plus 2nd by 2 is nothing but half of the top width. So half of top width of the channel is equal to, what is d into root of 1 plus n square? D into root of 1 plus n square is the sloping side of the channel. The length of the sloping side of this channel. So this is equal to the sloping side, or one of the sloping side. Okay, one of the sloping side. So this is your first condition. Condition 1. So first condition for the most economical trapezoidal channel section, that is b plus 2nd by 2, half of the top width is equal to d into square root of 1 plus n square, that is one of the sloping side. Now we will find the hydraulic mean depth, that is our condition 2. So we know hydraulic mean depth m is equal to a by p. Now what is area? From the first equation, area is b plus nd into d, and third equation, perimeter is b plus 2d into root of 1 plus n square. This you have to consider this. See, this perimeter is in terms of area. You should not consider perimeter in terms of area. You should consider this perimeter. Okay, so a by p. So area is b plus nd into d, Perimeter is b plus 2d into root of 1 plus n square. So area is b plus nd into d, and the perimeter is b plus 2d into root of 1 plus n square. So that is equal to, now we will substitute this first condition. We will substitute the first condition here. So what do we get is b plus nd into d divided by b plus 2 into this d into, listen, this d into root of 1 plus n square. Instead of d into root of 1 plus n square, we will substitute b plus 2nd by 2. So b plus 2 into b plus 2nd by 2. So you can cancel this 2. What we get is b plus nd into d divided by b plus 2nd. So what we get is m is equal to b plus nd into d divided by 2b plus 2nd, which is equal to b plus nd into d divided by, you can take 2 outside, you will get b plus nd. You can cancel b plus nd, we get d by 2. This is our second condition. So our second condition is m is equal to d by 2. M is equal to half of the hydraulic flow of water, hydraulic depth of water, flow of depth of water. M is equal to half of the depth of water. This is condition 2. So first condition is half of the top width is equal to one of the sloping side. Second condition is m is equal to d by 2. Hydraulic mean depth is equal to half of the flow depth of water. Now we have one more condition. So for that one more condition, we will draw once again the trapezoidal channel. So space will not be enough. Okay. For the next condition, we will draw the channel section once again. Okay. So we will take this as A, B, C and D. Now we will take this sloping side, this angle as theta, and we will draw a perpendicular from A to the bottom. So that is taken as ABCD. You can take this as E. Now this AE is nothing but the depth of flow, right? AE is nothing but the depth of flow. Now we will consider, see, if this is theta, if this angle is theta, this angle is also theta, because these both are horizontal lines, parallel lines. These both are parallel lines, and this is a sloping line meeting these two parallel lines. So adjacent angles are equal. So if this angle is theta, this angle also will be equal to theta. We will take the bottom width as B. Now let us consider the midpoint of the top width as O. See, this is different here. Let us take the mid width of the top width as O, midpoint of the top width as O. And from O, you draw a line perpendicular to the sloping side, and we will take this point as F. Draw a perpendicular line to the sloping side. So this angle is 90 degree and make this point as F. So as we all know, this is ND, right? So this will be, if we are taking one vertical to n horizontal, one vertical to n horizontal, let us take the slope as 1, n is to 1, one vertical and n horizontal, or n horizontal and 1 vertical. So this distance will be ND. So this distance will be ND. That means for one vertical, n horizontal. That means for D vertical, it is ND. Horizontal will be ND. Okay. So that is all. Now we will write the derivation. So hope you understood up to this. Okay. So now we will take the right angled triangle OAF. So taking the triangle OAF, sine theta will be equal to, so we are taking this triangle, right? So sine theta is equal to OF by OA. So OF by OA. So from which we get OF is equal to OA sine theta. Now we take this triangle AEB. So take triangle AEB. Sine theta will be equal to, taking triangle AEB, sine theta is equal to AE by AB. AE by AB. Now, we know AE is equal to D divided by AB is the sloping side, right? AB is the sloping side. We know the sloping side is D into square root of 1 plus n square. Here also the sloping side is D into square root of 1 plus n square. So it is D into square root of 1 plus n square. So we get sine theta is equal to 1 by square root of 1 plus n square. So we will take this as equation number 1, this as equation number 2. So substituting 2 in equation 1, we get, substituting 2 in 1, we get OF is equal to OA into sine theta is 1 by square root of 1 plus n square. Now what is OA? OA is half of the top width. Half of the top width. So this is B, right? This is B. So OA is equal to B by 2 plus ND. Or we can write this as B plus 2ND. AO is half of the top width. So AO is equal to B plus 2ND by 2. So OA is B plus 2ND by 2 into 1 by square root of 1 plus n square. So now already we have obtained the value of B in terms of D. That is our condition 1. So what is our condition 1? So hope you all remember the condition 1. What is condition 1? Half of the top width. That is half of, our condition 1 is half of the top width. That is B plus 2nd by 2. Half of top width is equal to one of the sloping side. That is d into root of 1 plus n square. So half of the top width. B plus 2nd by 2 can be replaced by d into square root of 1 plus n square. Multiplied by 1 by square root of n square plus 1. So we get OF is equal to, you can cancel this 1 plus n square, square root of 1 plus n square root of n square plus 1. So we get OF is equal to D. Now come to the diagram. OF is equal to D. That means OF is equal to the depth of flow. So if OF is equal to D, you can take here G. OG is equal to D. If you take the midpoint here, we can take it as H. OH will be equal to D. So that means you can draw a semicircle. You can draw a circle. I will draw it using another color. If you are drawing a semicircle with OS center and radius equal to the depth of flow. If you are drawing a semicircle with O as center and radius equal to depth of flow, the semicircle will be like this. Okay, that means the semicircle should touch all the three sides of the trapezoidal section. So this is the condition for most economical trapezoidal section. So from this, what we can obtain is, if a semicircle is drawn with O as center and radius equal to the depth of flow D, radius equal to the depth of flow 3, then the three sides of most economical trapezoidal section will be tangential to the semicircle. Okay, so see this side AB will be tangential to the semicircle, this BC will be tangential to the semicircle, and CD will be tangential to the semicircle. So we have three conditions. So this is our third condition, condition 3. So we have three conditions for the most economical trapezoidal section. Condition 1 is half of the top width, that is B plus 2nd by 2, half of the top width will be equal to one of the sloping side D into square root of 1 plus n square. And second condition is M is equal to D by 2. Hydraulic mean depth is equal to half of the flow depth. And the third condition is a semicircle drawn from the midpoint of the top width. That is drawn from O with radius equal to the depth of flow will touch the three sides of the channel. So remember these three conditions. And remember the two conditions for a rectangular channel is, most economical rectangular channel is, the breadth will be equal to 2 times depth of flow and hydraulic mean depth is equal to d by tau. Now we have one more section, that is a circular section. We will see the circular section in the next class, and after that we will move on to the problems related to this. Thank you for today.